Okay. So 5-4 is trig equations and inequalities. It says a graphing calculator approach. So in other words, we're going to use our calculator. So the reason we're doing this is sometimes trying to graph or solve these without a calculator is impossible. We don't have the tools or the knowledge available to us to do that. So instead of sitting here trying to beat our brains out about it, we're gonna work smarter, not harder. We're gonna use our calculator, okay? We're gonna just jump into this. Example 1. Find all real solutions for this. Now, when they say find real solutions, we need to be in radian mode. And I know we just switched to degrees, so make sure you change your mode back to radians, please. So, we know what this shape is. What is this shape? This right here is a line. What's the y-intercept? Negative 0.5. What's the slope? 0.2, which is up 1 over 5. It's a flat slope. So, we kind of know where we need to start looking. We know what it looks like. We can be smarter that way. So, what we're going to do in your calculator. I'm going to try to make this so there's no glare. But also so you can see it. Oh, beautiful right there. Okay, so let's, in the first one, go sine of x over 2, and the second one, 0.2x minus 0.5. And we're always going to start at zoom 7. All right. I definitely know there's something going on right here, yes? It definitely looks like that crosses right there. So find that intersection first because it looks good. So second, calculate, intersect. Is that the first curve? Beautiful. There's my second curve. Okay. And then we got to guess. Zoom 7. Make sure you're in radians. What'd you guys get? So we got x equals 0.5, oopsies, 5.161. So did you guys get that for your first point? Now, this one right here, I'm not 100% sure if it crosses or it doesn't cross. So we're going to use my favorite zoom ability. We're going to zoom box. I'm going to scroll way over here. That's where I made my box. Everybody's box will be a little different. That's okay. Oh, did it cross? Oh, sad day. It didn't cross. So we only have one answer. That's it. Moving on. Example 2. A rectangle is inscribed under this curve. With the width of the base as shown below. So here's what they give you. They have a picture in the book, which is much better than what I'm going to draw for you right now, but you get the idea. Oopsies, right there. 1, -1. This right here is this curve. And what they said is under this box, they've made a rectangle. They've inscribed a rectangle under a curve. That's what that means. And from here to here is x. Because that's on the x-axis, yes? Okay. So what they want us to find, A, is write the equation for the area of the rectangle. So what's the width, or the length of this box? The width of this box? 2x. Because it's a rectangle, so it's gonna be even under here. What is this? The height is the distance from the x-axis up to the curve. So what's the height of this? What if I said the x was at 0.5? How would we figure out where this would meet right here? We would put 0.5 in for x and get a number out, right? What if I said it went out to 0.8? What would we do? We'd put 0.8 in for x. Well, I'm not telling you what x is, but the height of the box is the equation of the curve. Because whatever x happens to be, the top corner is going to meet on the curve at that spot, and which is going to make the height of the box. The height of the box is always on that curve, so that's why the height of the box is the equation of the curve. Is that okay? Okay. Now how are we going to find the area of this? Times the two together. So we're going to have 2x times 2 cosine pi over 2x. There's our equation. Which is the same as 2 times 2 is, so we have 4x times the cosine of pi over 2x. That's our equation for the area of this box. Now part B says graph the equation and describe how the area changes as x goes from 0 to 1. Okay, so let's put this into our y equals, and we're going to look and see what happens to this curve. Now, they told me as x changes from 0 to 1, so in my window, I'm going to change my x from, I'm probably going to like negative 0.1 to 1.1. Oh, I zoomed box it. Let's go negative 4 to 4 again. That's normally what it is. I just liked it a little bit bigger than what they asked for. Nothing, I erased it. We're not finding an intersection. This better be nothing. Yeah. And then a graph. So, from 0 to 1, what happens to the area of the box? So, at 0, what's the area of the box? Nothing, is 0. And then what happens as x gets bigger? The area gets bigger until we hit a maximum. And then after we hit the maximum, what happens to the area of the box? It decreases. So there is a perfect, if we want to maximize this box, which I'm assuming they're going to ask us to, there is a good x that will maximize the area of this box. So, they want us to find the value. They don't want us to maximize it. Produce the area of 1. So, here, let's make this equal to 1 and find where it works. Is this okay? And it crosses there, and it crosses there. Can we find those intersections? Let's do it. Enter, enter, and there. Oopsies, there's a 7 right there. I got 0.275. and 0.797. Is that okay? Okay. Okay. Example 3. A 12 centimeter arc on a circle. Okay, so we got a circle. From here to here, I'm going to say it's 12 centimeters. Has a 10 centimeter chord. Oh, geometry. What is the radius? Okay, so here we go. Now the cool thing is if I draw in this diagonal right here, what's it do? Because this is an isosceles triangle. So what's it do to this base right here? Cuts it in half. And it also cuts the arc in half. So this right here is 6. And it makes a right triangle. And I'm going to call this theta. And this is the same triangle just over here. But I'm just going to focus on one of these triangles right now. Is that okay? Here's why we want to do that. I have 2 variables and I need 2 equations. If you have 2 unknowns, you need 2 equations to solve them. Well, the nice thing is in radians, we know that the arc length is equal to the radius times the theta. Well, what's the arc length right here? 6. So we know 6 equals r theta. And then we also have this right triangle in here. And we're looking at, so theta. What is the 5 in relation to the theta? It's a cross. So what do we say? It's opposite. And what's the r? Hypotenuse. So which ratio deals with opposite and hypotenuse? Sine. So we're going to say the sine of theta is equal to the opposite over hypotenuse. So do I have 2 equations with 2 unknowns? Yes. It's, yeah, just like a system of equations. So we're going to solve this for either r or theta. I suggest let's solve this one for r. Oh no, r theta. I don't care. What do you want to do? Okay, so let's solve for r. What are we going to do? Divide by theta. So r equals 6 over theta. So then you're going to take that and you're going to plug him in right there. So 5 over, but instead of an r, it's 6 over theta. We don't like to leave it like that, so just flip and multiply. So sine theta equals 5 theta over 6. And then we're going to use that calculator to figure out where that's true. So sine, uh-oh, but we're in theta, so what do we need to change to? Oh no, let's leave it in radians. I'm gonna ignore that. I don't like switching. Now our window is a little bit screwy, so what should we probably do? Zoom 7. Yep. Oh, there's the sine wave. Oh, we love him. Whoa. Craziness. Now, we're talking about radius, right? And we want an angle that it opened up in the circle. So am I worried about where it may have crossed down here? No, because that's negative, right? We don't want negative stuff. So I'm going to focus in, and I'm pretty sure it crossed in here. But what are we going to use to help us out? Zoom box. Here's our curve. Okay, it looks like it crossed here at 0, but am I worried about the 0, 0? No. But did it cross right here? Yep, so let's find that intersection. So I can calculate intersect. So for our theta, I got 1.027. Are you okay with that? Okay. Now, when you look back here, is that the whole angle? What's the whole angle going to be? It's double that. So 2.064. No, 54, not 6, 5. So that's the angle. But what else did they want from us? The radius. But if you remember, we had r equals 6 over theta. And we know what theta is, so can we find our radius? Yeah. So our radius is going to be 6 over theta. Yeah. So 5.842. What are centimeters? There it is. So, basically turned into a system of equations. What do you think? Not too bad. I think coming up with the equation is probably the hardest part of it.
So you guys all done with your proofs already?
Mm-hmm.
Wait, no one ever came over and asked me to help with it.
They don't come ask me either.
Is that because they all got it?
No. Heaven forbid they miss a soccer practice. Or baseball practice, or track practice, or whatever practice. Good. Oh, they give us a window range. That's super nice of them. They want us to look at this from 0 to 3 pi. So that's really cool. Okay, we're going to figure out where they cross. So, same thing we've been doing. Just put this into y1, put this into y2, and then we'll change our window. I'm going to do something really quick. All right. So tangent of x over 2, and what's the other side? 5x minus x squared. And they told us a window range, so we're going to go from 0 to 3 pi. Change this back to negative 4 to 4. We can change it if we need to change it. That's 3 pi. I just typed this in. Please don't try to do all the decimals. Just go 3 pi. Okay, there's the tangent. Oh, and there's our parabola. Beautiful. Do I see everything? No, we need to move it up. So what do you guys want to use for your max? 7? 7.5. No. Oh, beautiful. So, where's the first place this crosses? I wonder if it crosses right there. What do you think? I think so. Let's check it out. One way, if you think you know it crosses at 0, 0, if I went to the table and I typed in 0, what should they... Oh, look, they both equal 0. So does it cross there? Yes. So one of our answers is x equals 0. So back to our graph. Can we find the other two intersections? Yes. So, find your intersections, please. Actually, I'm going to cruise because we're almost out of time. The last one I want to hit, definitely, and I will give you homework whether we get this done or not. Example 5 is inequalities. So basically, we're going to be looking over an interval range. I have faith that you guys can find the intersection of those other 2 points on your calculator. We've done it enough. Yes? So for example 5, we want to know when cosine of x minus 2 sine of x is greater than 0.4 minus 0.4x. So this is going to give me a curve. This is a, what's this shape here? A straight line. And I want to know when the curve is greater than the line. So let's graph. Make sure you close parentheses around the x in your first in the trig function. Otherwise, it doesn't understand that you're talking about a new function. So you have to put parentheses there. And I'm going to zoom 7. There's my curve. I want to know when this is bigger. So I kind of got to pay attention. So it's definitely bigger from here to here, yes? So find this intersection and find this intersection, please. First of all, find both of those. What's the first one? Negative. Yeah, negative 2.09. Oh, not good. So that's where it starts being. And why didn't I put a hard bracket? Why did I put a soft bracket?
Because it's not bigger at all.
It's not. There's no equal bar. So it's a soft bracket, not a hard bracket. Remember that? That's reaching back. And then what you guys get is this intersection. Okay, so it's greater here to here. And then I know it goes less than, so I don't care about this, but I know it starts being bigger right here. So can we also find that intersection?
3.2.
So union 3.2. Now, I'm not sure if it crosses again over here. So should we maybe check it out? Yeah. So for our window, let's bump that out to 3 pi. How about? Oopsies. I hope it doesn't cross, because then we got to find another point. There it goes, there it goes, there it goes. And it doesn't cross again. So after this point, what is our curve is always going to be greater than our line. So go to infinity. That's your answer. So interval notation comes on back into our life, people. Woohoo! Okay, here's your homework. Okay, this is probably the nicest homework I've given you guys in a while. So there you go.